Okay, so the really amazing thing about this session is that we now have some realism because we've got some beautiful models that Rowan has put together. He provided me with those models by basically emailing me this Unity package file. And this Unity package file contains the model, the materials, the textures, and even animations that will really bring life to the visual experience. Now you can just drag this package in to the assets. What will happen when that gets detected by Unity is it will ask you what you want to bring in. And you can see these animations he's made here, materials, models, and he's even made a prefab which puts them all together. I'm going to cancel that because I've already brought them in, of course. But you can see here in the things that need updating that the animations, models, textures all came in very nicely. Now we actually ended up remaking the prefabs because as soon as you bring in a model from somebody that somebody's made, it may not well scale brilliantly with what you've already set up. So one of the things that we sort of had to do was to think about um, the size of all these things. So I want to keep the root of my model at sort of without scale and without rotation. Um, the actual mesh that Rowan made to represent the tube, um, it it needs to be rotated by 90 degrees on the x-axis, and it needed his lovely plastic clear material. A really key component was the bone base, and this is out of my league when it comes to understanding how these things are put together. But basically, the bone base allows us to have an animation where ultimately this hinge here is going to move. And in fact, we can actually see. Well, we'll see that happen when we get to it. I've actually rotated the bone base on the y-axis as well because I actually want the lid to be sort of at the back and just to the side. So that's why that y-axis rotation has been put in there. You can see that if I was to change that, you can see that moving along there. So these components here are what Rowan provided. Um, I brought in the liquid and the canvas from my previously existing tube prefab. Uh, and then it was a matter of just making the scale right. So that meant that in the models, what we had to do is change the scale factor in the model until it sort of was a commensurate with the size of the tubes that I'd set up previously. That was just done by fiddling about. There's no great equation to that. So having got that right, what we can then see is that the liquid component, I had to scale a little bit higher, so 1.1, just so that it would fit the width of the tube. And that was just about the only thing that I really had to do. The other extra thing I've added to the prefab is a little empty gain object sort of hovering above the tube, and that is going to be a spot where I'm going to pin the pipette dial so that as the pipette body moves up and down, the actual interface, the arrows and the input field will remain locked at that position. The pipette stays pretty much the same, except to cater for the the little size differential, I've actually made the pipette a bit bigger, so the model part of it is just scaled twofold to what it was. I can't remember what the size the barrel was and the tip was before, but they look about right there. The canvas, I think I made a little bit bigger. Oh, then that reminds me that on the prefab, I made the canvas there. I made that a little bit bigger as well, I think. Oh no, that's still scaled the same. Oh yes, it's tiny bit bigger on the height maybe. Certainly its position is changed so that it's a little bit off to the right and moved up a little bit there on the Y as well. Again, just fiddling around to get that right. No sort of codified way of doing that other than just playing around. Um, so uh, the the major differences then are in the scripting. So if we have a look at the pipette action script, before we had an action for sucking up and dispensing, and we noted that there was quite a lot of commonality between them and it would be better to accumulate them. So what I've done here is I've kept the conditions to check that there is an active tube, that there is something sensible written in the input field, and then the only difference to whether or not we adjust the volume negatively or positively is which direction we've told it to go in. And that direction is held on the arrow button here. So when we click on the button, we're either sucking up or we're dispensing. And at the moment, we only really need to know one of them. If it's suck up, we do the suck up. If it's not suck up, we're going to do the opposite. But I just, in Watson and Crick style, will say that the possibility that other options become available, like doing a full push through or of the pipette, when you do that, go take it to the second stop, something like that now becomes possible. Um, the other difference is that I've I've got rid of the magic number here on the pipette offset, the distance between the meniscus and the where the pipette's going to be. That will vary according to the pipette. If we're using a P2, a P200, a P5000, that distance is going to change. So this will be a sort of feature of the pipette. For this pipette that we're using at the moment, it's 2.1 is the nice distance. We're also going to get a reference to the top of the tube, to that spot where we want to pin the dial of the pipette. So when we transform the position of the pipette, send it to where the meniscus, above the meniscus, we're now doing that to something a little bit more codified, and we're also going to keep the canvas to the top of the tube. So we've got a reference to the canvas object on the pipette tip. I think the pipette guide is the same, and so the only other difference is in the liquid in the tube script. There we've got that pipette pin, that little spot where we're going to pin the dials of the pipette to a certain place above the tube. The other major difference is I've just renamed the maximum Y height to be the cylinder Y height, and it turns out to be something that you need to define as a property of the particular tube you're using. So again, just by looking and trial and error, it becomes obvious that the Y height that takes us from no microliters in the tube to the maximum possible that we can get in the tube is 1.6 unity units. And that represents a volume in this case of 2000 microliters or 2 mils. The meniscus height, the way that's defined might vary according to the tubes. For this particular context, it's actually whatever the cylinder height is times 2. And again, that might be different for different tube types. All right, so that sort of explains what happens. In the next sort of improvement, we'll actually get this so that, in fact, let's maximize the play. We'll actually get this so that we'll get some liquid happening within the pipette tip, and we'll also have some control over the opening and closing of the tip. And we'll introduce some rules about whether or not the pipette tip can go there, depending on whether it's open and closed, and whether, of course, the opening and closing can happen if there's a pipette tip there, because you can't close the lid if there's a pipette tip present.